All right, I'm with Chris Paul, CEO of Hercules Metals. Hercules is out with a news release today that is pretty impactful. I gave my thoughts on it this morning, but I feel there's a lot more to unpack. So we're going to dig in a bit here with Chris. Chris, how are you and what has you so excited?
Doing good, thanks, Rob. Well, I would say the bulk of the excitement is finally just having a model to work with, right? So if we kind of recap Hercules Metals history, we came out with this exploration, this silver exploration project. We made the Porphyry copper discovery 2023. That was the easy part, right? Believe it or not, that the easiest part of a discovery is drilling the discovery hole. That's when things get really tough. And what probably the market didn't appreciate was how difficult it then is to figure out, where you're at in the system, and B, where is it trending, right? And so 2024 was about taking a series of really big step outs and trying to figure that out. And with that comes misses. But it also came some good hits. And we were able to use those good hits our technical team was able to use those good hits and the structural oriented core information to actually piece together a 3D model. And it lined up with everything. It lined up with the geophysics. It lined up with the geochem. It was looking really good. But until you get out there and start drill testing it from this new northwest oriented drill plan, you just don't know. But obviously, from today's release, from release we put out a few weeks ago, we're obviously confident now that this model has been validated. So what does that mean? It means we can ramp up the drilling. We don't have to go one hole at a time, scratching our heads, trying to figure out what is this? Where are we? Where do we go next? It's like lay out the drill fences, right, which are a series of sort of cross sections along the model, and just drill it off. And so in a sense, we've gone from more or less greenfields targeting to pretty well definition drilling in a matter of just a few short months here this season. So that's what we're excited about.
Yeah, I mean, there's definitely a different flavor to the last three pieces of news that Hercules has published. And the CEO quote you put out today definitely smelled confident. It read confident, like you're confident in your targeting, you're confident in your model, and you're confident in what you're seeing. So, I'm going to start with the first hole of the program. So 2502, I mean, when you put out the news release June 23rd, I saw the drill trace for 2502. I read the comments about 2502, and then I saw the subsequent holes plan, and I said, that looks like they found something very encouraging in 2502 that had you then do the 2508, this almost near vertical hole that looks like it's off the same pad. So tell us what you can about what you're seeing in 2502 and 2508 and what has you moving to the northeast.
Yeah, certainly. Going to share my screen and start with the plan map. So the green represents the holes that we've now completed so far in 2025. So we got 5,500 meters drilled already. And as you can see, where we started was in what we call the hanging wall. Now this red outline in the middle that all the holes are going towards, this is what we've now modeled as the Leviathan porphyry. So this is your central porphyry intrusion. This is what brought all of the copper to the party. Okay, so the white lines, so when I refer to drill fences, a fence is basically a line, an imaginary plane, vertical plane, along which all your drilling is going to be. And so what I'll do here is I'll jump over to a cross section, and so this is what the model looks like in 2D cross section. And so actually I'll just refer back to this. So AA prime, this is the cross section line that was drawn through deposit. And we chose this area because it's got a series of 2023 and 2024 holes across it. So we've had two events here. You had your typical primary sort of main stage porphyry mineralizing event that brought all the chalcopyrite mineralization in. And where do we see that? It forms a shell around the top of these porphyry intrusions. So the pink here in the background, these are these southeast dipping porphyry intrusions that brought the metal to the party. And surrounding the sides and the top, when these things intruded, was all this copper mineralization. So around, call it 0.5% copper. The unique thing in Hercules, and this is what you only get in maybe a handful, less than 10 porphyries I know of around the world, is it didn't stop there. And the epithermal part of the system, right? So all porphyries, they form deep, but then shallower up, they have what's called an epithermal zone where there's essentially another mineralized center and up above in the shallow parts of the system. And if you're really lucky, there comes a time during the system where those two systems actually overlap. And that's what happened at Hercules. And that's what we're illustrating on the section on the right here. So all the blue is kind of your main stage chalcopyrite, and the pink is where this bornite, this epithermal bornite, has come down and overprinted that chalcopyrite and upgraded it to about maybe 2% copper. So when we were, we didn't have this model in 2023. We didn't have this model in 2024. And a lot of the holes were drilled subparallel to it, right? So hole 3 started off in the outside of the mineralization in what we call the pyrite halo. 2314 did the same thing on the other side, and 2414 was really far away. It was in what we call like the really distal, the green rock environment, the propylitic. And so what we said is this year, if this model is correct, we need to be drilling across the deposit, not parallel to it, where as your holes go down and if they're steeply oriented, for example, like hole 3 was steeply oriented at about -70, and the porphyries are dipping more like -45, well, you're only going to get further and further away. And in fact, the grades are going to drop the deeper you go because you're actually drilling away from it as you're going down. So hole 2 was the first hole of the program, right? So hole 1 started in some really tough rock. We don't want to waste money this year, so we said forget this. We'll pause it and let the RC rig come in and drill this. So hole 2 became the first hole, and we wanted to establish early on. We wanted to get at least one roughly kilometer deep hole that could go as far as it could across the system, because from one side of the hanging wall to the other side of the footwall is about a 1 kilometer width, right? So the central porphyries are about 500 meters wide. The scale bar down here is a 400-meter scale bar. So let's start on the hanging wall. Let's drill through this central porphyry, and let's drill out into the footwall. And that's what we did with hole 2. And that's why it went for such a distance. So if we point to that on the map, hole 2 is up here. And it was accomplishing 2 objectives. Objective number 1 is validating the model. Okay, so this model that we've come up with, where everything is dipping to the southeast, at moderate angles, maybe 45 degrees, should we have been starting over here and drilling all of our holes 45 degrees to the northwest? And the answer was yes. The answer was yes. And in fact, I would say within plus minus 20 meters, we were basically hitting what the model predicted, in terms of porphyry contacts, right? So we went down through the Jurassic cover where predicted. So we hit the unconformity and got into the porphyry where predicted by the model. We hit the hanging wall contact of the porphyry where predicted by the model, and we hit the footwall contact of the porphyry where predicted by the model. And we even got all the way through into the pyrite halo as predicted by the model. So obviously that was like, wow, like the break that we needed so badly on this project after 1.5 years of grinding it out, scratching your heads, trying to understand what the geometry of this first ever porphyry copper discovery in Idaho, probably the first porphyry copper discovery in the US in decades, to be honest, the first major porphyry copper discovery. So hole 2 was up here. The other objective, there was 2 objectives. The second objective was to step out on 2412. Now, I didn't put the grade bars on this map because it would be too noisy, but 2412 was one of the better holes that we've ever drilled. And in fact, the grades in 2412 persisted all the way down to the very bottom of the hole. So we knew that that was a good hole, and we wanted to both validate the model, but not just repeating stuff we already know. And so we did a 225 meter step out to the northeast towards an area we call the Great Creek Zone, which we're obviously very excited about. And so that was the objective number 2, and that's why we ended up drilling this ginormous shallow hole trace. I think it was a dip of around minus 60 or minus 65 in the end, because minus 45 is quite challenging. But yeah, that was what we were talking about in today's release when we talk about hole number 2, was this guy right here. So then from there, it's off to the races, right? Bring in more rigs. Okay, we've laid out all these white fences, and so you don't need to wait for results from each hole, figure out what's going on, and try and guess where to go next. We've obviously had the confidence to say, okay, well, we know this model is right. Let's define, properly define grade and width across this 1.3 kilometers that we know exists, right? By actually drilling across this in a series of fences. Okay, so start with that. That's our definition drilling. But from all the evidence we can see, there's probably a minimum 3.5 kilometers of total strike length. And that's just based on chargeability, magnetics, surface geochem, mapping, prospecting, right? That really only extends to about Grade Creek and Southern Flats. But we ended up doing this MT survey as well, because as far as we could see, the system continued beyond the limits of that 2023 survey. There was no reason it just stopped at the survey boundary. So yeah, things are progressing really quickly.
Okay, so 2502 was a breakthrough drill hole. That's pretty clear. You kind of just laid out that's exactly what happened. Can you explain to us, so 2508, you drill from the same pad, but now you're drilling a basically near vertical hole there. What is the objective of that? And then there's a bunch of others. So basically the results of 2502 encouraged you enough that you decided we have to gradually step out in increments to the northeast towards the Great Creek Zone. Is that right?
Yep. So hole 8, neither of those holes are shown on this cross section, right? Because this is just meant to be an illustrative cross section through the model based on previous years drilling, because we don't have assays back for any of these new holes. So Hole 2, if we were on that particular cross section, would have been collared somewhere that, right around here, right around where 2420 was, and drilling, across the system. The system's dipping southeast. So by drilling a vertical hole, you can also test the down dip extent of the southeast dipping system as well, right? So you're testing the shallow parts with hole 2, and then you're testing down dip with hole 8. I mean, you could just keep on going, right? You could drill, one shallow hole, one deep hole, move on to the next fence, one shallow hole, one deep hole. But I think probably we'd be looking at 2 drill pads because you don't want to be drilling 1,000-meter holes on every hole. They're slow going and they're challenging. Hole 2 was done, as a first step, validate the model, drill across the whole thing. But now that we've done that, you can have 1 pad above the hanging wall zone, 1 pad above the footwall zone, and drill 1 or 2 holes off of each pad, and that's what each fence is going to look like. Now multiply that by each one of these white lines, and you start to get a sense of how big the system is that's being tested here, right?
Yeah, I mean, that's really the takeaway from today's news release, is just how much the potential has grown here. And I mean, everybody can sort of do their calculations at home. I mean, until we get assays, it's not really, very useful to do those calculations, but you can try. But yeah, wow. I mean, the fact that this is 1,300 meters of known strike extent now, but it could grow beyond 3,000 meters based upon what you're seeing in the model and in the IP, the chargeability, and now the new MT survey. The high-grade hypogene enrichment. So there's this concept that there's a potential for preservation of high-grade enrichment, basically thicker zones of this to the northeast past 2412. Can you explain that to the viewers? Like, why is the likelihood that the high-grade enrichment could be thicker to the north?
Absolutely. I'm going to reshare my screen here so that you get a proper full screen view. Okay, so we talked about on that previous cross section that there was the second event. So you had the main stage porphyry, like every porphyry gets. Your chalcopyrite is grading somewhere around 0.5% copper when you're in that ore shell, but then the epithermal system overlapped with it and enhanced the grade to 2% copper. Now, we had Jamie Wilkinson come in. So Jamie actually consults for Barrick. And so Barrick brought him in to do a study on just the enrichment zone mineralization, try and figure out what it is. Right, because you remember there was a lot of arguing, people calling it a supergene blanket and this and that, and obviously this had to be put to rest. And the result was that no, there's absolutely nothing supergene about this. Number one, bornite is not a supergene mineral. You'll never get bornite in a supergene enrichment blanket at surface. Bornite does not form at surface, but he did this whole study. He confirmed for about 12 other reasons that it's absolutely hypogene in nature. Now, the interesting thing is Jamie Wilkinson is currently, he's done a ton of work down at Resolution Copper. And he's even currently publishing a paper right now as we speak. And he was kind enough to insert a cross-section where he's restored what Resolution would have looked like before it got kind of tilted and there was post-mineral kind of stuff. And so this cross-section here is what Resolution looked like. And so there's this red outline. This is the enrichment zone. So this is their 2% copper zone. And that's really all you need to focus on here. And then there was erosion, just like happened at Hercules. There was erosion. as represented by the black line called the unconformity. That's how deeply the system was eroded. And then you get this leach cap, right, which is shown in yellow here as supergene. That's supergene leaching. So you got part of it was leached out, but fortunately at resolution, the leaching basically didn't seem to take out any of their enrichment, and they had this giant, almost 2 billion ton, 2% copper resource there. And so Jamie did this interpretation. So he looked at it and he said, look, everything about this is resolution. Everything, right? Like this is basically the exact same processes that happened at resolution. And he even compares two of, we call them thin sections, these microscopic images side by side. And so Hercules enrichment zone on the left, right, with all of the alteration and mineralization, resolution enrichment zone on the right. And so, they're identical. They're bang on. They're one of the same alteration mineralization. And so he went ahead and he drafted up this cross section. And what we're trying to illustrate here is that the enrichment zone is dipping, or it's plunging, right? It's not perfectly flat, like maybe we used to interpret it on some of our early sections. It's dipping, right? And what that means is that when the erosion came through and started taking out some of our enrichment blanket, which we know happened in the discovery area, for instance, 2305, there was a leach cap, right, that had taken out part of that enrichment zone. So we don't know how thick the enrichment zone originally was at Hercules, or at Leviathan rather. It may have been 500 meters thick of 2% copper, but nonetheless, at least this part of it here, where Hercules drilling was, only intercepted maybe 50 meters, or 50 to 100 meters thickness of it, and then you go into kind of low grade. So what Jamie's done is he said, look, guys, it's dipping, and so what you're going to get is as you start to move along strike, and the erosional surface, the unconformity and the leaching is not going to take out as much of it, right? So in other words, the erosion took out all the up dip part of it here, but you might have 500 meter thick zone of 2% copper as you guys start to step out along strike, because there was tilting at Hercules too, right? So before it was eroded, everything was tilted about 45 degrees, right? So when you get that tilting happening and then you erode it, this is basically, if that makes sense, this is where the discovery zone was. Now we start to trace this down plunge and see, does it start to get thicker and thicker and thicker as we get away from that erosion and leaching?
So maybe a dumb question, but at Grade Creek, the elevation goes up to the top of the cliff, and then the actual creek is a very steep drop off right into the creek. So you haven't actually drilled a hole at the actual Grade Creek yet, but you're working your way up to the top of the cliff. So are you saying that the tilting and the topography may have saved a very thick portion of high-grade enrichment at Grade Creek?
Yes. Yeah. So think about it like this. I'm gonna focus you back on the camera here. Okay. So I'm gonna just sketch in, kind of what the enrichment blanket looked like. All right. So you formed the main stage porphyry copper, and then telescoping down these structures right at the top here. So imagine this booklet is Leviathan porphyry. It's tabular, right? So you've got the strike length, you've got the depth below surface, and you've got the thickness, right? We know it's about 500 meters thick, and all along the shallow part of that porphyry is where, let's go back to the cross section here, right, is where this enrichment telescope down it. So in other words, it telescoped down the shallow part of this porphyry intrusion. Now, if you imagine all of this stuff at the top, and it's going to come down little structures as well, right? So all of this material at the top was bornite, and then everything below it is chalcopyrite, right? It's the lower grade main stage porphyry mineralization. So here's all your enrichment up at the top. Now, you tilt it 45 degrees to the north, right? So this is Grade Creek, right? And this is basically, you know, maybe where 2419 or 2420 or, you know, those holes are around here.
Yeah.
So you tilt it like this. So Grade Creek essentially takes a nosedive into the ground, and the enrichment, this nice thick zone of enrichment is plunging down towards Grade Creek. Now, imagine where at the top of my view here, imagine this is the ground surface, right? And so that enrichment forms, and then it starts to tilt, and then you see you start to erode it, right? You start to erode it away, right? So erosion starts to take away and starts to eat up some of that enrichment like this. But Grade Creek down here, right? Here's your erosional surface up at the top here, right? The enrichment is plunging, right? So it's the top of the enrichment is still sitting below that unconformity. It's still sitting below that erosional surface. So theoretically, as we continue to step northeast, you're gonna start to see what the full thickness of that enrichment zone was. We don't know how thick it was. We have no idea, right? Because we've only seen the part of it which was partially eroded. So how thick is the full thing? Could be 500 meters for all we know.
Wow. Okay. All right. So that makes sense. That was a good explanation. So now, you know, let's stay in the Grade Creek zone and let's talk about the expansion potential to the north. So there's a couple things in the news release basically saying you have another 1,000+ meters of chargeability high to the edge of the survey to the northeast that you haven't tested yet. And then there's also this discovery of porphyry vein boulders to the northeast at Green Creek. So how do you put the pieces of those puzzles together, and what does it tell you?
Okay. So let's start with the basics, right? So we know that this black outline here in this image is the Leviathan porphyry modeled so far, right? And that's only because we've only got so many holes into it. I think only 3 or 4 holes actually tagged into it while we were guessing where it was. But it's trending northeast southwest. So we have no idea how much further it's going to keep going to the northeast. We have no idea how much further it's going to keep going to the south. But it's bigger than 1.3 kilometers. We know that. Now, what evidence, because it's not at surface, it is blind, it is concealed. So what lines of evidence do we have in support of extension, in support of it being bigger? Well, number one, chargeability, right? So chargeability is a great tool for telling you how much disseminated sulfide is in the ground. It correlates beautifully with the known mineralization in the hanging wall and the known mineralization in the footwall, and that same anomaly continues. And this is just a zoom in. This is focused on Grade Creek. That same anomaly continues all the way to the northern border of our survey, right? So we stopped surveying at Grade Creek in 2023. So the highest values continue all the way to the edge of the survey and beyond. So that's reason number one, that the system obviously extends in that direction. Reason number two is the magnetics. So you can clearly see, here's your porphyry is modeled, northeast, southwest. Here's your mag anomaly, northeast, southwest. Note, importantly, there's no break here, right? So there's no offset in this mag anomaly across the creek. In other words, Doesn't look like there's any big fault there, right? It doesn't look like it just stops and hits the brakes. Reason number 3 is the geochem. So we're not really sure. This was all the sampling work, all the surface sampling work was done in 2022, long before we knew there was a porphyry even here. And we got 2 copper anomalies, 2 copper moly anomalies. We got one big one in what we call the Eastern Block Zone. We know about that. It's parallel with Leviathan. So in other words, it's northeast, southwest. It shows the same style of geometry, but it's different. It's not Leviathan. It's a different center. We don't know anything about it at this stage. It's a conceptual target. We don't know where the center is. We just don't know what it is, but it's not Leviathan. Why do I know it's not Leviathan? Hole 2414, which was somewhere, it was drilled somewhere down in here. Now, if we flip back to this slide here, notice where 2414 is. So we were in the green rock environment. So we weren't in the pyrite halo. We weren't in the QSP, phylloccultured zone. We weren't in the potassic. We were way out in the green rock environment. So we know that we were at least a certain distance from the center in 2414. So what does that tell us? That tells us that the Eastern Block is not a part of this, because you cannot have green rock environment, you know, in the middle of one big system, right? Does that make sense? Right? This is sort of evidence that clearly there's an intervening distal alteration zone in between Leviathan and Eastern Block. Okay, so that's Eastern Block. But then we get this other anomaly, right? So these are like really, if you look on Google Earth, these are really steep cliffs. And we've never actually been able to go back and map them. We had these 2 young mountain goats from Idaho go down and risk their lives pretty well to get these samples. But the values, actually, if you look at some of our old press releases, we used to like post the values of like the soils and everything like that, and they were multi-thousand ppm. So that's a big difference from this 500 ppm anomaly, right? They're order of magnitude higher. Now, the question has always been, I'm sure you're wondering this because you're a Hercules bull, you're a Hercules guru, you know everything about this thing. If you look at the maps, right, this is supposed to be cover. So this black line here, this represents the unconformity, right? So we go back to the cross section. The unconformity, when I say the word unconformity, that all that means is the boundary between Jurassic cover, post-mineral cover, which has silver, but that's another story, and Triassic porphyry system, right? And so that plane, that unconformity plane, outcrops in a line across the surface, right? And so it outcrops on the side of the hill here, and downslope, you've got Triassic rocks exposed, and upslope, it's just cover. You can't see anything, right? So if this is the boundary and everything to the west of this black line is all covered with post-mineral cover, then what the heck, why is there a porphyry copper moly anomaly at surface here? Now, we're not sure, if I'm being perfectly honest. And why is it so strong? Why is it also the strongest with thousands of ppm copper and all this and that? Well, the only thing I can think is Great Creek is a canyon. So it's a really fast moving river. And what it's done is it's really rapidly eroded down through that cover. And all I can think is the only thing that makes sense is you've incised a channel down through the cover. The cover's thin, right? So when you approach the unconformity, the cover gets quite thin. The further west you go, the deeper the cover gets. So the closer you are to the unconformity line on surface, that's one way of estimating how thick the cover is and like what the open pit potential is versus underground block cave kind of potential stuff. But all I can think is that Grade Creek did kind of like what this thing did here, right? It eroded some sort of a channel down and has somehow exposed a window through the Jurassic cover with really
light bulb moment. Yeah, that makes a lot of sense. Yeah.
So and then the last thing, the last line of it. So obviously there's one reason to believe that that this represents an erosional window along the northeastern extension. But we don't actually see it. Like, you know, we've gone below the cliffs, we can't find Jurassic. All we can see is Jurassic rock. So it's a bit strange, but it's there. The last line of evidence, and I'm sorry, we're gonna get in the weeds a little bit. So, you know, all the people.
It's hard not to get in the weeds.
I know.
With Hercules.
If you don't like geology, don't watch this video. You know, go watch something else. But for people that kind of like this stuff, we're going to do it. And what we're going to talk about is the red conglomerate. So at the base of that Jurassic cover, right? So the first unit to be deposited was something we call the red conglomerate. And so the red conglomerate formed when in the Triassic, the Porphyry had formed, and it had come all the way up to surface, and then you just started to erode the very top of the Porphyry. And when you erode the top of something with these river channels, so if you got river channels running across the Porphyry that's at surface, like imagine going to the Golden Triangle right now, today, and you walk over Galore Creek or whatever Porphyry systems are exposed at surface there, and there's a river running across that Porphyry. And you know, if you go and pick up any of the boulders in that river, you're probably going to be porphyry, right? They're going to be porphyry altered. They're going to be porphyry veined. That river is just picking up boulders and moving them a very short distance. So that's what the red conglomerate is. So that's essentially the first geological layer that's deposited on top of the porphyry. And so what's interesting about that, and then you get all this other, you know, volcanics and other stuff on top of that. What's interesting about that is that becomes now a very, very, very interesting prospecting tool, because simply by looking at what's in that river channel, right? What are the boulders and everything that are being eroded? It literally tells you what's beneath it. It tells you what's sitting directly beneath that conglomerate unit, what's directly beneath the cover. So in other words, the river was flowing towards the southeast. So imagine this thing is just a river picking up big boulders of leach cap and whatever else, and it's flowing this way. Well, it's outcropping right here, right? So if you find a red conglomerate outcrop right here, and you look inside of that, it's going to have basically all these boulders of whatever was right here, right? And so as you walk along strike, you're either going to see strongly altered and strongly mineralized boulders if it was over the porphyry, or if you go 20 kilometers away, you're going to see a bunch of boring, unaltered, you know, garbage, because there was no porphyry system underneath. So does that make sense? I know
it makes a lot of sense, actually. Yeah, that's another big light bulb moment. So the porphyry vein boulders at Grade Creek are very important clues. The red conglomerate now holds important clues that you could use in future drill holes. I want to ask one more question about the Grade Creek area, then I want to go to the south. So what does the MT survey show you about the Grade Creek area? Are there any clues that you can glean from the MT survey?
Yes. but I wasn't done going into the weeds. We're almost there.
Okay.
We're in the jungle. We're in the jungle. We're not, you know, we're almost at the target here. So I just want to show you what they look like because they're impressive. So these are the boulders that we that are coming out of the red conglomerate. And when I mean like 100% of the boulders of the class inside the conglomerate look like this. So for perspective, for non-technical people, this is probably the most juiced up looking alteration, veining you could see across the whole Leviathan deposit as we know it. It's been leached, right? So it's been, because it's sat at surface, so it's oxidized. So the sulfides are gone. But any good geologist knows that red burgundy hematite like this comes after bornite or other copper sulfides. So what this is basically telling us is this got plucked up from somewhere underneath Great Creek, somewhere underneath the cover, under Great Creek, transported maybe 100 feet, 300 feet, and then settled, you know, on this riverbed, which is now exposed, is now outcropping on this little tiny thin line at surface, which is basically telling us this is what's sitting underneath Great Creek.
Wow, that is an extra clue that is worth tuning in for. Wow. Okay.
So to give you another example, right? And this, let's look at core. So this is hole 12, right? I thought it was a good example of what happens, right? So here's your porphyry copper system. This is like the leach cap transitioning down into unoxidized. You're going from oxidized weather to unoxidized. So as you can see, above the porphyry is what we call that red conglomerate, right? So this river channel that ran across the top of the porphyry and has deposited all these little boulders and these fine sand beds and things like that. So this is what the red conglomerate looks like in drill core, and directly below it is altered porphyry, which has been oxidized and leached. But then as you go deeper down, so you go down, you know, from 928 feet to, you know, 1,000 something, you'll see that red burgundy hematite turns to bornite, right? So pretty exciting.
Light bulb. Wow. Yeah. That's a very nice detail clue.
And by the way,
yeah,
that wasn't found in Great Creek. That was found probably 500 meters past it.
Oh, to the north of the actual creek.
So if this is the Great Creek zone, right, and this is the Great Creek, there's a road that switchbacks down, right? And this is basically where all the drill pads are going next year for our Forest Service permit that we're going to have ahead of next year. And then the road crosses the creek and forks in two directions. And these are old mining roads. So there's all these old mines down in Great Creek. And so one of the roads went left, right? It went west. One of the roads went northeast up the hill, right? Up in this direction. And the prospectors were digging on this stuff. So literally those clasts I just showed you in that last image there, we found those in prospect pits. So the old timers were seeing the red conglomerate. It had copper oxide on it. So in other words, like all these boulders that have been eroded and you know, from underneath the cover still had a little bit of copper in them, and were oxidizing and covered in malachite and copper oxide. And so the old timers were thinking, wow, there's a copper deposit here, and digging on it, not realizing that these are just boulders, you know, coming from, you know, maybe 100, 300 feet away underneath all this Jurassic cover. They had no clue. So yeah, I mean, this is, you know, we're now getting like 1.5 kilometers northeast of hole 2 at this point. And I'd say
Wow.
visual right there of those rocks that are directly underneath the cover. I mean, I don't think you can really get a better tool for seeing undercover than exactly that right there.
Okay, well, so what you just delved into and explained to us was definitely worth the price of admission for this conversation. But let's move halfway south and go to basically the middle of the project area that I would say is right in between Great Creek and Southern Flat. So like holes 2504, 2509, 2503, 2505. So they're obviously following up on last year's hole 2420. That was an exciting hole for a number of reasons. First of all, it was higher grade, 0.7% copper equivalent, 300 meters of 0.7%. And there was a nice enrichment blanket in hole 2420, and it was really shallow. So instead of the porphyry starting at 200 or 250 meters downhole depth, it started at like 75 meters. So that was really encouraging. So what can you tell us about that central portion of the porphyry deposit?
Honestly, not much more than what you just summarized, right? So we know from last year's drilling that sort of south central part of the porphyry in the hanging wall is really good. And so it's simply a matter of going back and drilling it properly. So even hole 19, which was, deviated really hard. I don't know. Yeah, that's it right there. Deviated really hard, right? Thanks to the RC drill going too deep and a number of other reasons, but it was drilled subparallel. 2420 was this one here. So drilled sort of west southwest, right? And so still suboptimal. So we know there's obviously a good area there. We know it's in the hanging wall. Another key reason you'll notice all of our holes, all the green ones and all the blue ones, they're all on the hanging wall side, right? Can you guess why? Why are we starting on the hanging wall side? Why is that our priority right now? It's not grade. What
So
else?
you could get a thicker interval.
You can get a thicker interval, but you can get a thicker interval closer to surface.
Yeah, okay.
Right, because you're closer to the unconformity. So, if this thing's going to work, you're going to want a starter pit of some sort. I mean, there's sort of two targets, right? So one is the high grade 2% copper enrichment zone. Finding that thickened and preserved underneath Great Creek or maybe even underneath Southern Flats. I don't know. But we know that there's enrichment here. Proof of concept was the first few holes into it where it was only 50 meters thick. But I mean, we're going to get into some stuff soon here that's showing like ridiculous strike lengths that still have to be drilled. So somewhere along strike, that 50 meters of 2%, could very easily turn to 500 meters if we find the entire preserve zone, right? So that's the underground target. But in the meanwhile, why don't we start, if we're gonna re-drill Leviathan, if we're gonna re-drill the 1.3 kilometers that we've already modeled, right? Because it's got to be re-drilled because the drilling was parallel. Like it just, you don't want to build an inferred resource on parallel drilling. You have to drill across it. You have to drill perpendicular. Yeah. It has to be systematic. So why don't we start close to the unconformity? So hole 20 was only, right, the mineralization was only 70 meters below surface there. So shallower, much shallower. And that's why we're obviously focused the initial drilling on the hanging wall target. Simply because of that. Simply because we're trying to see if there might happen to be a nice little starter pit here.
Yeah, nice little starter pit there by 2420. Okay.
Yeah. And then yeah, just simply from there, we're just drilling northwest across it instead of, you know, sub-parallel to it, like the previous drilling. So that's really all it's doing. It's definition drilling at the end of the day. It's grid-based definition drilling.
Got it. Okay, so now the big takeaway from this morning's news release, in my opinion, is 2506 and the MT survey, which shows this large anomaly extending far to the south throughout Southern Flat. So tell us about hole 2506 and, you know, what's the objective of this hole and what have you learned so far?
Right. So the MT, let's start with the MT. If I'm going to be honest, we had this company, Mumbaraga, come out. They're a very popular company. They do a lot of surveys for majors and things like that. Now, a few years back, you know, or maybe it was 2 years back, you know, we won the award, you know, the TSX-V top 50 thing or whatever, where, you know, we had this function and Filo's there, NGX is there, all these great companies there. I got a chance to talk with the Filo guys, and we got into geophysics because it turns out they had used DS to do 3D IP. And I was like, well, how, you know, is that, no, it just wasn't, it was okay, right? It was okay. But they said, look, the real light bulb moment for us was when we did this MT survey, and they did this MT in 2023. And it's just, they said, you know, for them, which, you know, comparable type of processes in terms of, they started with that shallow silver, epithermal silver, which transitions and overlaps with a deeper porphyry system, and they got that overlapping zone with enrichment. And so I thought, okay, well, it's worth trying, but, you know, I had my hopes, I didn't have my hopes high, obviously, right? Because it's geophysics. And, you know, as far as I was aware, you know, chargeability is always the best kind of geophysical technique in porphyries for directly detecting mineralization. In other words, the pink blobs are your target. That's like what you're actually drilling into. Whereas other things, you know, other types of surveys like resistivity and stuff, you know, maybe better for like faults and mapping and, you know, just sort of giving you the big picture, but not saying drill here. But we got just preliminary results back, right? So we did, I forget how many stations, but, you know, we did this massive 120 square kilometer area. We press released that recently too. So you can see the map of this huge area that was covered. And the reason we did that is because that chargeability anomaly was open on both ends. So we had this 12 square kilometer IP, 3D IP from DIAS from 2023. We have a northeast to kind of south trending anomaly that's lit up by Leviathan going across the whole thing end to end, right? So it's obviously open on both ends. So let's see. I mean, we can't realistically also run wire, right? Like with IP up and over these mountains, and, you know, it just gets hard. So we tried the MTO, and we did it as a joint survey between us and Scout Discoveries. So Curtis wanted to sort of join in. I think, you know, it was a good benefit, and having a larger area actually allows you to see deeper. So we can actually image down reliably over 6 kilometers. So when we're halfway done the survey, we hadn't done any of this northeast stuff yet. So we hadn't really done any of the survey up towards Great Creek yet. But when we're halfway done, Ben, the geophysicist, gave us, you know, very quick and dirty sort of preliminary inversion, right? Just to, you know, maybe I'm gonna help you guys see some of the big picture stuff. So we got that back, and oh my God, there is a conductivity anomaly. So with MT, you're getting resistivity, right? And the inverse of resistivity is conductivity. So either something's really conductive or it's really resistive, right? One way or the other. So what I've done in this release and in these cross sections that you can see on this slide is I've shown low resistivity as warm colors. So in other words, the pink blobs are your conductivity anomalies. And what is absolutely remarkable is that the Leviathan, all the mineralization, the block model, the porphyry, everything, this big southeast dipping system lights up. It lights up like crazy, and it's like a perfect correlation. So yeah, I was completely wrong. It absolutely is direct detecting the mineralization, and it's showing you the geometry of it.
Wow.
Right? So pretty remarkable. Now keep in mind, this is preliminary. So not only, you know, we've got this 1 kilometer station spacing. This is phase 1. We've still got to come back and do phase 2, right? Where we actually, so phase 1 is just figure out what's the interesting anomaly in here. Phase 2, once you know where it's at, then you come in and do some tightly spaced infill, and you actually get proper definition on it. You find exactly how wide it is, where it's centered. You know, it's kind of right now, because of the really broad station space, you know, we might have a station over here and a station over here, right? So, you know, we need to get better definition on exactly where this thing is centered. But this anomaly correlates beautifully, perfectly with that 1.3 kilometer strike length that we've modeled so far, right? Where we've got the copper block model and the porphyry model, but then it just keeps going. And as you step south and south and south, that anomaly just keeps going and going and going and going. And in fact, it gets stronger. So Leviathan, that the part we've modeled, the part we've drilled, is less than 100 ohm meters, which is fairly conductive. But as you get towards hole 6, where we're drilling right now, it actually starts to get really strong, right? And you start to get values below 50 ohm meters, which is the bottom section here. So what we've done is we've shown 2 sections. One is through Leviathan, just showing you the correlation there. And then we've shown the same thing, just stepped a kilometer to the south, right? Looking in the same direction where hole 6 is currently going down right now. And so, yeah, we're basically targeting the center of this less than 50 ohm meter anomaly here. And I don't know, I think it's probably one of the most exciting targets that we have going. So yeah, all of a sudden the Southern Flats has just become like this, like potentially even more exciting than Great Creek now.
So hole 2506 is in the Triassic, and it's targeting the center of the MT anomaly, the very pronounced sub 50 ohm meter anomaly there at Southern Flats. And also, Southern Flats is the area of the project that has the best host rocks. Is that correct?
Yes. I wasn't even going to bring that up, but yeah, you can't slip anything past you. That's pretty good memory, man. Because that was like 6-7 news releases ago when we talked about it.
Yeah, but it was impactful at the time. I'm like, yeah, Southern Flats is a very high priority target area, and so and now it's being drilled. And it's interesting that you're in Porphyry, but it seems like you're on the edge of maybe the sweet spot.
Yeah. Okay, so let's back it up. So the nearest hole that we have is 2419. 2419 was drilled suboptimally. We ended in a late porphyry. We ended up, so we got down through this really nice zone. It even had enrichment. The silver grade was really high, so it's telling you that, you know, you were in that nice sweet spot where the porphyry overlaps the epithermal part of the system. And then because it was drilled subparallel with all these porphyries, we got into a late phase of the porphyry. And once you get into it, you stay in it. You don't get out of it, right? Maybe I can show you a cross section so you know what I mean. So, yeah, it's not, well, this hole is kind of off section, but this is the late porphyry, right? So it kind of hangs out, kind of in the pyrite halo, but sort of fringing some of the copper grades too. And so it basically went down straight parallel, and then it's not shown, but actually ended in this thing. And once, you know, we could have drilled down this thing for another 700 meters of just late porphyry, right? So, you know, that's why, again, getting back to your other question about, you know, why we're drilling 2419 and 2420 is we have no idea how thick this zone actually is around 2419 and 20, you know, we're
Right.
drilling northwest across it. But then, so this is the furthest south that we've drilled on Leviathan, is 2419. Now jump back to the plan map. 2419 is right here. And there's a number of fences that we could have drilled between it, but we didn't want to start. I mean, it's a long story, but I don't know why we did this, but we decided to take this ginormous 800-meter step out to the south because of it. You know, it's a nice big flat area. We know there's no groundwater there. There's no artesian. We did get an artesian somewhere in this valley here. So essentially we said, let's skip the whole valley. We don't want to deal with an artesian hole. Let's skip this whole valley and let's go to the next ridge over. So we had to go 800 meters to the south. So it's a big swing. And we did not slowly trace the porphyry out this way, but we've got the MT anomaly, right? We've got the MT to sort of show us where we're at. So yeah, this hole's in progress now. It's currently paused, if you can believe it. Well, right, we've got we've got 3 drill contractors. We got the RC, we got Dorado, and we got Scout. So Scout had one really powerful rig and one somewhat less powerful rig, which is still good, but we've swapped. Scout's just purchased a new Hydrocore 5000, and so what was drilling hole 6 was a Hydrocore 2000. And so now that they've got this 5000, we've kind of moved the 2000 off. We've moved it down the highway. It's demobbing, and we're moving the 5000 more powerful rig, which is just more cost efficient at the end of the day. And so it's currently paused, but that's where it's at, and it's going to go right boom into the center of this 50 ohm meter anomaly and see what 50 ohm meters does for us.
Yeah, so for people who may not be so technical in understanding IP chargeability, the MT survey and what it measures, when the MT inversion is showing a body that is so conductive in a porphyry setting, what are the options for what minerals could be exhibiting that kind of an anomaly?
So that's a great question, and the way we look at it as geologists interpreting the data is it's all relative to what the host rock is. And so sedimentary host rocks with a lot of carbon in them tend to, when they get sort of heated up and metamorphosed and cooked a little bit, they'll go to graphite. So graphite will be really, really conductive. Now, there is a separate terrain to the northwest of Hercules called the Baker terrain, which is full of that stuff. It's full of seds and graphite and all this sort of stuff. We know for certain that we are not in sedimentary rock. We are in what's called igneous rock. So igneous rock is like really crystalline, lots of quartz and lots of feldspar, big crystals of it. And that's basically what the Triassic package is here. So everything below the cover, everything that this big anomaly is extending down through and into, this is all volcanic rock. And volcanic rock is very resistive. So if you get a super, super, super strong conductivity anomaly in what is a background of just really resistant rock, that tells you, and it's porphyry copper system. I mean, we've said in the release that we're in the system, right? We're in the volcanic rocks, we're in the pyrite halo, so we're in the porphyry system. And so what that means is all that conductivity is basically from the sulfide content of the rock and the alteration. So in the really high grade zone at Hercules, we get a lot of clay alteration. So the rock gets altered to clay and a mineral we call sericite. It's sort of moderately conductive. So the alteration in the porphyry system is conductive, but the sulfide minerals are really what's driving this conductivity anomaly. And so the stronger the conductivity is basically telling you in this anomaly, this one right here in particular, what's in the Triassic, the more sulfide mineral that is present. So basically it's saying that there's something, there's more sulfide in this southern part of the system here under Southern Flats than there is in the part of Leviathan that we've drilled previously.
And the fact that this is a complete wildcat hole into an undrilled area, and it's in this favorable host rock environment. I mean, just like clue. So many boxes being checked for how exciting this hole is and how exciting it could be. I guess my final question is, like, it seems like it's a pretty deep hole. I mean, obviously, as long as you're getting positive feedback from the drill core, you're probably going to let it run. But I mean, how deep could this possibly go?
We don't know, right? I mean, if we drilled through the entire anomaly, I mean, we might go to 6,000 feet for all we know.
Oh, God.
Right? If we tag into this really hot stuff here, and keep in mind the spatial accuracy of this is also a little bit poor because it's preliminary. We haven't done the infill yet, right? So it may be a little offset. It may be over here, maybe, but whatever. I mean, yeah, we could end up going very deep. And look, the last thing we'll just talk about here is getting back to why we did this in the first place. And I hate using Filo as a comparison, right? Because it's kind of, it's like, it's a little bit overly promotional, but in this case, it's absolutely relevant. It's the reason, we did it. So this, when you look back at Filo's news releases, they did this MT survey in 2023, and according to those guys, this was the light bulb moment. This was the tool for defining the porphyry copper system at Filo del Sol. And so you'll notice after they did this survey, every single plan map that they put out on every single news release would always show the same figure: 2023 MT survey, 600 meters below topography, and they would show this big sausage-shaped anomaly. And so what this did for them is they started up here in God knows 2003 or whatever, because they had that shallow epithermal silver system. What they then realized is that shallow epithermal silver system was being fed by a much bigger porphyry copper system deep down to the northeast, called the Aurora and I think the Bonita zone, but mostly the Aurora zone is where the really high grade was, because Aurora is where the epithermal silver part of the system overlapped with the porphyry system, right? So this is where they ended up finding their hypogene enrichment, all focused in here. But this is again preliminary stuff, but sneak peek. This is a similar depth slice of what this just preliminary, and this is unconstrained, right? This is a big square, but there's only the sites are only I guess in here roughly right now. We still need to, we haven't got the data up here, and we haven't got the data down here, right? It's only based on half the sites so far, and it's a preliminary version, but you're seeing that same sausage-shaped anomaly extending off of Leviathan, right? So it's sort of weak to moderate here. This is what, like, for scale, this is 1.3 kilometers, right? This is a 7.5 kilometer scale bar. Right, if we just measure, let's say from here, this is starting to get upwards of. We said 4 kilometers in the news release because it sounds ridiculous if you say 10 kilometers.
Yeah, wow.
What's showing, right? And until we constrain it and find out, we're seeing essentially the exact same feature that those guys saw and led to that light bulb moment for them. Now, ignore all this. We don't know what this is yet. Like, there's obviously a big fault zone. There's some different rocks over here. But for now, Leviathan is lighting up. It's, you've seen the cross section. It's southeast dipping. If we just cut a cross section, right? You see it, right? It lines up beautifully. That is measuring the width, right? There's 2 kilometers by 3 kilometers. So yeah, I don't know. I'm obviously incredibly excited to come back, keep infilling this thing, getting our final inversions. I would say probably in about 2 weeks from now, you know, we're gonna probably have the final inversion product based on this joint survey that we did with Scout. But man, it's a big boy. It's a big system.
I feel like, you know, we could go for another hour, but I just want to give you a few more questions while I have you, just things that are really like burning questions. So if it's 2 kilometers wide and possibly 2 kilometers deep, and the strike extent is potentially 3 kilometers, 4 kilometers, I mean, you know, we just don't know, but it's huge. I mean, I can't think of other porphyries that are of this kind of scale. I mean, you know, is this one porphyry system, or is it possible that there's been multiple intrusions that have popped up, you know, along this trend, and that's kind of what we're seeing in these anomalies, whether it's over in Western Deeps or at Southern Flats? You know, I'm trying to wrap my head around, if Southern Flats is the same system, I mean, the scale is just, it's huge.
It's huge. It's huge. So look, I can't comment on personal communications I've had with Rio, but this is a project they call Pole Creek, right? So when the staking war happened, this is where they went. And I know that they had some data from a company that they acquired who had drilled here. I think in the 1970s, they'd done a big regional reconnaissance program, and they'd honed it on this Pole Creek area, and they drilled it. And again, I can't comment on some of the information, but there's a reason that the Rio is here staking this Pole Creek thing and doing exploration work and now permitting for drilling. That's public. So there's 3 companies that are currently permitting with the U.S. Forest Service for drilling right now. One is Idaho Metals, who have a big block up here, obviously Scout, and the third is Rio Tinto. So 3 companies are now advanced to the stage of drilling, and Rio obviously has a porphyry target that they're going after here that they must know of from some of this previous drilling. And so yeah, with that anomaly extending all the way down here, I mean, you know, again, there's the scale bar, 5K. Is it all one big giant mega system that does in fact extend for 10, 15 kilometers? Or is it more of a string of pearls effect where you have this big regional structure, a bend in the regional structure, which, you know, is often where ore bodies tend to get in place. Actually, that's kind of another interesting thing, right? When you get big 70-kilometer long regional structures that go really tap really deep metal sources, which we know is what's happened here, because it's been reactivated 20 million years later to form all that epithermal silver stuff in the Jurassic, right? So there's obviously a really big regional structure. It trends northeast southwest across the entire belt, and what Barrick has staked all these epithermal silver prospects in the Jurassic, knowing full well that what fed those Jurassic epithermal silver deposits is that same structure, that same big structure that tapped really deep and was reactivated, you know, many times over and over again over a 20 million year period. So probably the string of pearls where porphyries are in place, usually at intersections, right? So either intersections along that big structure, or quite often where that structure bends. Because what happens is, you know, when a structure bends, it opens up open space, and that's where porphyries can come up, intrude into, and there's lots of sort of like a low pressure zone where hydrothermal fluids can escape to and deposit metals. So obviously we've got a bend in the structure where we're at, and it seems to be trending down into Rio's ground. But yeah, I mean, there's probably a dozen porphyries in this belt still to be discovered over the next 5 years.
Wow. Okay, so final two questions. I have to ask you about the Western Deeps. I know you got your plate full with the main strike extent area now potentially up to 3,600 meters, but Western Deeps is just so interesting, and you have a slide in the new presentation that talks about exotic copper potential. So I got to ask, you think you're going to get a hole into the Western Deeps here soon?
Yeah, it's possible. It's possible. So we're sort of saving that for the end. If you look at it from the perspective of the junior, you got a bird in hand that we call Leviathan. We've got extremely compelling evidence that it's a monster, and that it could be upwards of 10 kilometers. I mean, we say 3.5, but that's being conservative. Like, let's be real, based on everything that we just discussed, now that you've seen it. So the focus 100% is where you're getting a ton of joy, right? If we know there's high grade hypogene enrichment, we know there's massive scale, you're obviously going to focus. We've got this 12,000 meter program. We're financed for 12,000 meters. You want to focus those 12,000 meters to get the best possible results before you go and raise money again, right? So yeah, look, maybe there's a hole at Western Deeps, maybe not. I mean, look, the Eastern Block is the same deal, right? It's two in the bush. Right, if that makes sense.
Yeah. All right, final question. Again, like, we could go for hours at this. Obviously, investors always talking about finances and the potential for financing. That's just the nature of the junior mining industry. Companies have to raise money to drill. So what is the situation with the financing or the finances of the company?
Yeah, so I mean, like I just mentioned, we are financed for this 12,000 meter drill program that we're executing. Obviously, the junior exploration model is developed around. I mean, the reason we're public is to continue to raise money. And the key to being successful in this business is you raise your money at the most opportune times when you have them. Obviously, some breakthrough catalyst that comes out and moves the stock price up. I mean, we've always done it in the past, so have I guess trust the process and knowing that of course the company is going to raise more money, and of course we want to upsize the drilling program now that 12,000 meters isn't going to cover all these white fences. But yeah, look, there's a ton of opportunities available to us, and when the time is right, we'll execute.
All right, and the final question. In the news release today, it said assays in 6 to 8 weeks. It said several holes have been sent to the lab. 6 to 8 weeks sounds to me like Beaver Creek. It sounds like you're saying we'll have the first result in time for Beaver Creek. Is that what you're saying? Is there any chance we could get anything sooner?
It's kind of the tradition.
All right.
Beaver Creek.
Beaver Creek it is.
Yeah.
All right, Chris. This was a fantastic conversation. Very wide ranging. I think you taught me a lot in this, and I appreciate your time.
Thanks very much, Robert.